All right, so we have to be politically correct from now on.
You say we have a problem with that?
Huh?
You're trying to say we have a problem with that?
Uh, Not necessarily, but we do get off track sometimes.
Should I leave?
That's why you're here. Okay. Today's all about antennas and a little bit about, actually not anything about transmission lines per se, about matching. Some of the weird matches. Yep, it's not going to work today. Oh, maybe if I turn it on. No. Battery's good. I don't know. Okay, so even do not disturb it. Some of the basic things we'll talk about is radiation resistance will be very confusing, gain and beam width, antenna efficiency, and effective radiated power. So antennas don't actually have gain per se. Say what? Whose mic's on?
Think you want to silence the other students?
No, it's just no. Okay. Because basically an antenna is, in theory, you get out what you put in. Of course, in the real world, you don't quite do that. One of the ways they try to measure the so-called gain is to go around with a field strength meter, if you have a calibrated one, and actually measure the field strength in a circle around it to come up with these radiation patterns and see whether it matches what you do in a simulator like EasyNet. When they talk about gain, what they really mean is the ratio of the signal strength in the direction that you want versus the radiation in a reference antenna, which is usually either the isotropic antenna, which is totally theoretical, point source, which would be a sphere, and sometimes the dipole, where the gain in the dipole is actually measurable and it makes a good reference. They claim it's 2.15 dB higher than the isotropic. I've read stuff where they have different numbers, but in the textbooks it says 2.15. That's the theoretical one. And also, they tend to measure these things in free space, which is also unrealistic. Because when you get it, I guess, within a couple wavelengths of the ground, it starts to affect it. And we refer to the gain relative to the isotropic in dBi, or dBs relative to the isotropic. When we talk about it reference to a dipole, it's dBd. So what is an isotropic antenna?
Charlie.
Very good. Okay, the next one, which is kind of the most of the antennas are essentially some form of a half-wave dipole. Even a vertical quarter wave has the other half of the dipole in the ground or in radials or the ground plane. Like I said, it has some relative gain over the isotropic because it is somewhat directional. It transmits broadside in a not exactly a figure-8 pattern, but similar to that. And like I mentioned, the 2.15 dB is the reference that they use to compare the two. So some of the problems they'll give you, and you have to convert, you got to remember to use the 2.15 number to add or subtract, depending on which way you're going. So how much gain does an antenna have compared to a half wavelength dipole when it has 6 dB gain over an isotropic antenna? This happens to be one of those questions.
All you need is math, like 3.8.
All you need is math. You don't even need a calculator.
Alpha.
I'll take an alpha.
Take alpha delta a little bit. Right?
Subtract a little bit. I can still do that in my head. It's a challenge, but I can still do it. Okay, we talk about effective radiated power. And one of the bands, refresh me, which one it is that's 1 or is it 1 watt for?
That's the real low, the 1600,
Yeah.
160 kilohertz or something like that.
Yeah.
And it's relative to how close you are to Alaska, right? Or how close you
Well,
are.
there's another.
Yeah,
up in
that
Alaska,
the North Line or whatever it is, there's another.
rule in Alaska. And then there's actually two bands in it.
Okay.
You have to register with a power company or something like
Right,
that.
because that's the signal, that's the frequency they use to control the substation.
Right, we're secondary users.
The 600 megahertz
Okay.
or 600
No,
meters.
Kilohertz.
Oh, no, it's not even 600.
600 meter. And it's like.
Oh, yeah, whatever that is.
Yeah.
I mean,
That I can't divide in my head.
This guy.
Okay.
This is way off hard.
So we say that it has gain in the direction the antenna is pointing, if it's a dipole or one of the beam antennas. So in some of the cases we talked about, you need to know the effective radiated power. So you have to add up the gain of the antenna and subtract the losses of the system, like your feed line and some losses in the antenna, for instance. It becomes a bigger problem or an issue when you're talking VHF and UHF because of higher losses due to the frequency. And in most cases, all the regulations are peak effective power, not effective radiated power. So an example, if you had a 150 watt transmitter, you had 2 dB feed line loss, 2.2 dB duplexer loss, and a 7 dB antenna over a dipole, some kind of beam. You just add all those up, or the powers, subtract, and you get to use your calculator to do the anti-log of 2.8 dB, which is 1.905. Does everybody know how to do that?
With
your calculator.
No, don't go to a bank.
No, the anti-log when you're doing dB, find out what the ratio is.
It's the log.
Inverse log on your calculator.
Well,
It's got that.
how about, you know,
Divide by
yeah.
10.
Well, you
Take 10
you
to
take
the. Go ahead, Jesse.
No, I was gonna say you take the 2.8 divided by 10, and on your calculator you have like a log function, and then you got like a 10 to x, which typically is a shift. And you in other words, this thing is 10 raised to 0.28,
Right.
which you can
Take 10 to the power of the dB divided by 10.
Right.
10 times the log. So
right.
when you work at the inverse, that's why it's 0.28 instead of 2.8.
Right.
Well, I don't any of that math because I got 150 watts and the end result is 2.8 dB, which is close to 3 dB, and 3 dB
There you go.
doubles the power, so it's 150 doubling is 200. So if I look at the MPV or something close to 300. without doing.
But if you're a perfectionist, then you do it the other way with your calculator.
But if you really want to make it really.
Just look in the book.
Yeah, just look in the book. All right,
Just use your watt meter.
there you go. Okay, so what term describes station output, taking into account all gains and losses?
Or
Charlie.
What's the effective radiated power relative to a dipole repeater with 150 watts, 2 dB feed line loss, 2.2 dB duplexer loss, and 7 dB antenna gain? Sounds familiar.
Mhm. Yeah, something just talked. 286 watts.
All right.
Well, minus.
Now,
Huh?
at what point are you getting that gain? I mean,
From the antenna.
Antenna gain.
you got.
So it's going to be something other than a dipole because it's 7 dB relative to a dipole. So it's a Yagi or a quad or something. No. Steve wanted to know if I bought the ALS 600. What's they changed the numbers, work it the same
Yeah.
way. So 200 watts, 4 dB feed line loss, duplexer loss. So I think that adds up to what? 1 dB?
That's 7.2 dB loss.
Plus
Plus a
0.8, so it's 8
dB loss, so you got 2 dB
2 dB.
gain.
And
It's
that's
alpha.
2 dB.
Everybody go with alpha?
I don't know what the input was. Forgot.
Again, if it was 3, that'd be
200 watts.
400 watts. It was 3, so it's 2, something a little bit less. So 317. You can throw up without doing that.
317 watts.
Only a true optimist would pick B.
Yeah. Wouldn't that be illegal?
It would.
What's the effective isotropic radiated power of a repeater with 200 watts? 2 dB feed line loss, 2.8 dB duplexer loss, and 1.2 dB circulator loss with a 7 dBi antenna gain.
About the same thing.
Well, remember your gain's not as high. It's 2.15 less than the other one.
Isotropic.
Yeah, that's kind of a tricky one. You got to remember it's isotropic.
Yeah.
Baker.
Baker. I believe, because I just did 2 extra exams Thursday night, and I believe one of those questions popped up. Since there's 3 of them like that, there's fairly good chance that's the one you get. Feed point impedance is, I guess, one of the most basic antenna parameters that you worry about, as you try to match it to minimize the amount of loss to get the maximum amount of power to the antenna. It's affected by the things like the antenna height, the conductor length diameter ratio. The wider the or larger the diameter of the conductors affects the Q and the bandwidth. Anything nearby, metal, will have an effect on it. Other antennas, metal roofs. When I listen to some of Dave Castor's things, he talks about antennas, and it's everything affects everything. Angle of the wires, as you, for a dipole, as you lower them, it reduces the impedance, and as you lower it to the ground, it reduces it also.
Well, talk to Bob about angle of wires and this small yardage and be figuring it out.
Yes, it's going to be a W probably. Well, they do that on the hex beam, so why not?
Use your neighbor's.
All the trees are along the rear property line, right under the power line. Not my first choice. Okay, so the free space impedance of a half wavelength dipole is claimed to be around 72 ohms. I've seen it where it's 73 plus some little bit of reactance, but that's in free space. As you get it close to the ground, it tends to change. Does it ever go up?
Let's go down as you get closer to the ground.
I don't know the answer.
Because I know as you get closer to the ground, it lowers.
Well, it's gonna max at what, about 72
If
ohms?
it's unbalanced, it gets higher,
Okay.
because that, like, off center bed, you're off a little bit, gonna raise the impedance.
Okay. So which of the following factors affects the feed point impedance? Did I hear a bravo out there?
Bravo.
Bravo.
Okay, radiation resistance. It's defined as, it's kind of like the way they define RMS value. It's the value of a resistance that would dissipate the same amount of power as that radiated from an antenna.
Is that what they use lead shielding for, increased radiation resistance?
Yeah. That would do. Actually, it's a good thing because that determines how much power you're actually radiating, because it's I squared times the radiation resistance is the actual radiated power. And when you take the ohmic loss, which is the next one, that makes up the total feed point impedance. It's a combination of the radiation resistance and the ohmic resistance, which is the pure resistance of the conductors. So the sum, I mean, total resistance is the sum of those. And the ohmic is, and they define it as the system. It feels confusing to me because if you are talking just the antenna, you'd only worry about the ohmic resistance to the antenna. But in their definition, it's the system. So it's the feed line and everything in between, including the antenna, to get the efficiency. So what is the radiation resistance of an antenna?
Doggy.
Doggy.
Charlie,
Let's see, radiation resistance.
Remember, it's that definition with the
Cal.
equivalent to heat. Yeah,
Charlie, yeah.
Charlie. So what is included in the total resistance of an antenna system?
Delta.
All right.
This is my congressman that said suspected scammer.
Okay. So to calculate efficiency, you divide the radiation resistance by the total resistance. It's also been defined as the radiated power divided by the input power. But I'm not sure how you measure the radiated power unless you had a field strength meter. So what is antenna efficiency? Bravo sounds good. Okay, vertical antennas. They're sometimes called inefficient antennas. I can verify that. I have one. It works on all bands. But gain is like zip.
Ineffectively.
Well, compared to other things, it's they claim that one of the reasons they get or they're not as efficient is because of the radials where they may not even have any. Mine manufacturer claims doesn't require them, so I don't have any. And I guess
Require it too. Doesn't say it's gonna radiate.
yeah.
Well,
Well,
that's where the inefficiency comes in, when they say it doesn't need rating.
they only claim that it's below 2 SWR across all bands, and
Right,
it does do that.
so it's a light bulbs.
Right. Plus I'd have to put the radials 35 feet up, right? And if I made them around a quarter wave, that'd be really a mess.
Yes.
You have to have a lot of them.
Yeah. Well, at least 4. Get you started.
But get good ground flow.
Right. Uh,
But, well, radios don't have to go in a straight line. They can wiggle.
right. What you're trying to do is create a ground plane, a
Yeah.
reflective plane. And the more of them you have, the less holes you have in there. So more it looks like a solid,
Right,
which is what you would really love, is a solid piece of copper
it's just like,
or water.
it's the same as your antenna, dipole, it doesn't never go in a straight line, it can zigzag around.
Right.
Your direction may change, but it'll still function quite well, and you can match it.
You can buy stuff put into the ground to improve the ground. Properties of your soil,
Yeah.
and then we'll just spread that out there if you don't like.
Spread a lot of salt.
Yeah, but salt.
Yeah, but it's good to your grass.
I know.
This is good, you don't have to pay for a lot.
I think it was magnesium sulfate or something. They
Okay.
got something in there.
And that sort of ties in with the last one there about the soil conductivity. I'm not sure how ours rates. We're kind of wet sand, so it's not.
It depends upon the season and how far in you are. If you're in sandy soil and it's dry, that time of year it's sucky. But if it's rainy, it's pretty good, especially if you have a little bit of humus on top.
I was going to change the depth of, your ground flow.
Yeah.
If it's rained recently, you
Yeah.
have maybe a better ground plane effect. And then as time goes on without rain, seems like your SWR probably would change a little bit because it's not as efficient.
Yeah. Well, here in Merritt Island, there's water tables like 5 or 6 feet down. So, and it's becoming more saltwater, which is good for this purpose. But anyway, if you got bad soil, you've got a high ohmic resistance. So it's going to make a.
But one thing, if you do QRP work, like at Kelly Park,
Yeah.
so forth, put your antenna right in the water,
Yeah.
works real good.
And we'll be at Manteco, which is on Indian River.
That
Yeah.
works real good.
And that's salty, right?
Oh, yeah.
And that's where you could use like a vertical dipole right at the water's edge. They're very effective right at the water's edge, but at your house, they're not.
Okay.
So I'm hearing is I need a 12 flag pole and a moat in my front yard.
There you go.
That'll work.
Big moat.
salt-
Bigger the better.
Yeah, saltwater moat.
Get a houseboat.
Which of the following improves the efficiency of a ground mounted quarter wave vertical antenna? Yeah, since they call that a quarter wave vertical, so it's half of a dipole. Where's the other half of the dipole? In the ground, right?
Alpha.
Hmm?
He said alpha, I said bond, we.
Okay. Which of the following factors determines ground losses for a ground mounted vertical operating in the 3 to 30 megahertz or HF band?
Charlie.
Very good. You're doing good, Michael.
Can
I read
sit
the lesson
beside-
beforehand.
Can I sit beside you during the exam?
Sure.
When selecting an antenna, you need to consider the bandwidth. So they define it as the frequency range over which the antenna satisfies a performance requirement, which is kind of up to you. A lot of times they'll say an SWR of 2.1 or less. A lot of manufacturers will specify their antennas that way. My vertical that's what they claim. And when I've measured it, it's always below 2.1, not a lot. Depends on the band.
My performance requirement is 3 to 1.
Ooh,
Your tuner will easily tune 3 to 1, so.
yeah.
I mean, not that you're not losing some performance.
But you got, depending on that, how far away your tuner is from the antenna.
So you're just tricking your transmitter into outputting all but your antenna performance may not be that good.
Right.
If it's 3 to 1, you're gonna make your.
If it's 3 to 1 at the antenna, it's still 3 to 1 at the antenna,
Right.
whatever you do.
Yeah.
So, you've got a standing wave coming back down the transmission line to your quote tuner.
The antenna tuner is really not from tuning the antenna.
Right.
To
It's
keep
the
your
main-
transmitter from.
Right.
It's a matching unit. And I don't know where the tuner thing came from, but it's stuck.
Yeah, it is,
And everybody calls them antenna tuners.
This
Really
is
not
why
appropriate time.
remote tuners right at the antenna is the best, because this way you don't have
Right.
loss in your transmission.
Standing waves on your transmission line.
Right.
Yeah.
It's like having a variable balun that
Yeah.
you can, an adjustable balun, basically. So,
At the end.
I basically made my car antenna. Took a 102-inch CV with homemade coil, get up to about 31 feet and just put a SGC matching unit right at the bottom. So I could do 80 meters, no problem.
Because can you talk anyway?
Oh, yeah. Yeah, I'd be on the
Next door neighbor.
yeah.
I'd be on a dive trip, going down south, talking to someone in South America or something like that. So.
Okay. All right. Oh. Where did I hit that? What is antenna bandwidth? It's one of those generic definitions.
Baker.
Performance requirement. Whatever it is.
Huh? Right. Whatever your performance requirement is. 3 to 1, 2 to 1, 1.5 to 1. I like better. Okay. Where? Guess I can see it better here.